A vector space is a collection of vectors that satisfy certain axioms or properties. The axioms for a vector space are closure under addition, closure under scalar multiplication, commutativity, associativity, distributivity, and the existence of a zero vector and additive inverse. A vector is an element of a vector space. The zero vector is the unique vector in a vector space that satisfies the property of being the additive identity. A scalar is a member of the field over which the vector space is defined, usually the real numbers or complex numbers. Scalar multiplication is the operation of multiplying a vector by a scalar. Addition is the operation of adding two vectors. Subtraction is the operation of subtracting one vector from another. Linear independence is a property of a set of vectors in which no vector can be expressed as a linear combination of the others. A basis for a vector space is a set of linearly independent vectors that span the entire space. The dimension of a vector space is the number of vectors in any basis for the space. A linear transformation is a function that maps vectors from one vector space to another in a way that preserves the vector space structure. Eigenvalues and eigenvectors are important concepts in linear algebra, describing how a linear transformation affects certain vectors in a space. Inner products are a way of defining a notion of angle or orthogonality between vectors in a vector space. Orthogonal bases are sets of vectors that are pairwise orthogonal, have an inner product of 0, and have unit length. A subspace is a subset of a vector space that is itself a vector space under the same operations. A linear combination of vectors is a sum of scalar multiples of those vectors. The span of a set of vectors is the set of all possible linear combinations of those vectors. A linearly dependent set of vectors is a set of vectors where at least one vector can be expressed as a linear combination of the others. A linearly independent set of vectors is a set of vectors where no vector can be expressed as a linear combination of the others. The rank of a matrix is the dimension of the column space, or row space, of the matrix, which is a vector space. The null space, or kernel, of a matrix is the set of vectors that are mapped to the zero vector by the matrix. A linear transformation is invertible if and only if it is bijective, meaning it is both injective, one-to-one, and surjective, onto. The determinant of a matrix is a scalar value that describes how the matrix scales the volume of a region in space. A diagonalizable matrix is a square matrix that can be expressed as a product of a diagonal matrix and a matrix of eigenvectors. A symmetric matrix is a square matrix that is equal to its own transpose. A positive definite matrix is a symmetric matrix where all eigenvalues are positive, and it has certain desirable properties in optimization and machine learning. The Gram-Schmidt process is a method for orthonormalizing a set of vectors in a vector space.